Well guys, welcome to my 7th online tutorial on differentiation. Today we are going to look at the implicit differentiation. Right, so first of all let's see what is an explicit function and what is an implicit function. So first of all we look at the explicit function. Here you can see y equals x to the power 3 minus 2x squared plus 4. So here you can see y is in the left hand side of the equation and all the x values are in the right hand side of the equation. An explicit function is an equation such that you have all the y values in one side and all the x values in the other side clearly separated. But if you look at an implicit function, that's different. You have both x and y values, but the problem is you cannot separate them to one side. You have both x and y values together. So as you cannot separate them into an explicit function, we have to follow a special way of differentiation in order to differentiate this, right? So, and if I just talk about the explicit function, you can, by just using the power rule of differentiation, you can differentiate this. But here to do the implicit function, we have to follow a 4-step procedure. We'll look at the 4 steps now. Right, so this is our equation. The step 1, we differentiate this equation just as we have differentiated all other equations with respect to x. Now here you can see you have a y3. Now here we are going to differentiate the y with respect to x. So then using the power rule of differentiation, y3 can be differentiated as 3y squared. 3 will come to the front and you will deduct 1 from 3, that will become 2. But as we are differentiating y with respect to x, we will get dy over dx here and minus x squared. Using the power rule of differentiation, that will be 2x, and you have a plus xy, that is a multiplication of x and y. So we have to use the product rule to differentiate it. So we use the product rule, x times dy over dx, that is the differentiation of the y function, plus y times differentiation of the x function, that will be just 1, and then you can keep it in a bracket, and then you can simplify that in the next step. So you will get 3y squared dy over dx minus 2x plus x times dy over dx plus y equal to 0. That's the step 1, differentiation of the implicit function with respect to x. In the step 2, we are going to take all the components of the equation which contains dy over dx to a single side. Now here we take dy over dx and you can see 3y squared plus x. So you separate that and then you have dy over dx times 3y squared plus x, and the rest of the function minus 2x plus y will be like that. So now what we have done here is we have separated all the components of the function which contains dy over dx. That's the step 2. In the step 3, we take the rest of the values which does not include dy over dx to the other side of the function. So now here you can see that we have dy over dx 3y squared plus x in one side equal 2x minus y. What you have done here is this minus 2x is taken to this side as plus 2x and this plus y is taken to the other side as minus y. So now you have clearly separated the components which contain dy over dx and the rest of the function. Now the 4th step is a very simple one. You just take the coefficient of dy over dx, that is 3y squared plus x, to the other side of the function, and that will be the differentiated answer. So the final answer is dy over dx equal to 2x minus y, that is here, and then this 3y squared plus x will come as the denominator here. So this is how you can use the implicit differentiation in order to differentiate a function where x and y cannot be clearly separated. And thank you for listening, and await more online tutorials on differentiation.